Memory. Computers use many types of memory to perform various functions. Some of these memory types are, first one we mentioned here is the cache memory, used as a scratch pad for the microprocessor for repetitive operations, stores frequently used commands, and read ahead. So we have the cache memory here. This is the fastest memory in the computer, and we'll talk about the speeds here in just a few moments. Then there is the BIOS. This is the basic input-output system for the computer. This is way down here. We would refer to this as ROM, read-only memory. When your computer first starts up, there's a program that's stored in ROM that your processor will retrieve and execute that will actually perform the basic startup of your machine and perform a test called POST. Then there is internal memory. That is going to be right here. Internal memory, the bulk of the information, programs, and partial results are stored here during program execution. Internal memory is referred to as RAM. Okay, random access memory. Actually, cache memories are called RAM too, but since it's so small, we typically just when we say RAM, we're talking about this. And then there is video memory, dedicated to the storage of video information. And so here we have video memory over here, and that is for purposes of video. Okay, just a little bit about these. The microprocessor, it will ideally, it wants to interact with cache memory. And if we had a sample system, and I'm just going to throw some numbers out, not because they're necessarily numbers you see on current machines, but because it makes the math easier if I just do some real foundational numbers here. Let's pretend that we have a 1 gigahertz processor, and it's interfacing with memory that goes at 100 megahertz. And one day I had a student come to me, and he said, why should I spend the money on a 1 gigahertz processor? And this was a few years ago, because now they're much faster than that. But at any rate, he asked me about why should I buy a 1 gigahertz processor when RAM only goes at 100 megahertz. Now, if you do the math here, you'll see that the processor is going 10 times faster than the RAM is capable of going. And so the question is very apropos, really, because here I'm going to spend all this money on a fast processor, but can it really do anything, because it has to interface with RAM that can only go, 1 pulse for every 10 of these. And so, is it a wise investment? Well, what he did not realize was that there is something up here called cache memory, and there's something called level 1 and level 2 cache. And cache memory typically is right on the processor. It's not a separate component like RAM. And cache is extremely fast. And cache memory, actually portion of cache, the level 1 cache, usually can go at the same speed as the processor. So if this is 1 gigahertz processor, then the level 1 cache would be capable of that 1 gigahertz speed. And it has to do with the fact that cache memory is constructed differently. Actually, it's made out of transistors and flip-flops, whereas internal regular RAM is actually a function of capacitors. But we won't get into the detail here. But at this point, I'm just talking about the speeds. And so, ideally, your processor does its interfacing with the cache. And you'll note that there is a small, actually it's a relatively small amount of memory that goes at the 1 gigahertz speed. And then there is the level 2 cache, and usually it goes at about half the speed of the processor. So in this explanation, that would be about 500 megahertz. And so, in the grand scheme of things, remember we have this thing here called the system controller, and actually the system controller, it interfaces with the cache as well. But the processor ideally does its interfacing with cache. And when it needs a command, it first looks in cache, and if cache has it, it can immediately process it, and if it's in the level 1 cache. If it can't get what it needs from the level 1 cache, it looks into level 2. And if it can get it there, it slows down slightly, but not much. Now, if it is not in either of the caches, then it has to slow down quite a bit. This is a 10-to-1 change here, where it has to get stuff out of internal memory. And if it's not available in internal memory, then it slows down to whatever it needs to do to get the information it needs, either through the hard drive or through PCI or ISA or whatever. But in theory, the processor's interaction is going to be primarily with the cache. Now, this doesn't always happen. And one of the things we did not mention is its system controller down here. One of the things that it is doing, it is monitoring what is the microprocessor asking for. And based on what it asks for, one of the things it does is notice here at read ahead, is that it will read ahead in RAM and load the commands that it anticipates that the microprocessor is going to ask for next into the cache memory. So anyway, to answer that student's questions from a long time ago, the system actually can utilize this 1 gigahertz processor, but it needs a cache to do so. And so this memory that we call cache is of very great importance to the performance of a given PC. And then we did mention video memory here. I don't have a whole lot to say about video memory, except that it is just becoming in larger and larger pieces as video cards advance. Video memory usually is typically very large now. Also, another item is that many video controllers now are set up so that they can actually share the internal RAM as well as their onboard video memory. So that's often something that you will see available in modern PCs. Okay, the video controller is used in conjunction with the AGP bus, okay, right here, to coordinate video operations and display functions. Sometimes it is integrated to share system memory. I just mentioned that. It provides interface to drive CRT, that'd be a cathode ray tube, or digital display devices. Now these days the CRTs are kind of fading away. Now when you go into a computer store, all you're seeing is the digital display devices, and those one of the main claims to fame. In fact, there's a couple things that are very nice about those. One is that they consume a lot less electricity, and probably the thing that people really like about them is they take up a lot less space than a CRT. And concerning the AGP bus, in the earlier sections, we talked quite a bit about the interface with AGP 1, 2, 4, and 8, so I won't go into any more detail about that. Okay, audio circuits in a computer accept inputs and provide outputs. Typically, they are PCI, and here I can got a graphic here showing the audio inputs. They're usually on a plug-in card, but sometimes they are integrated into a system board, and so by that I mean oftentimes they're on a card that would plug into either the PCI bus or the ISA bus. But on some systems, just to produce systems more cheaply, what they'll do is all the audio functions will be placed on an IC, and it's just soldered into the system board. Now that makes the system cheaper, but it makes upgrades kind of difficult. Okay, features sophisticated drivers, specialized sound effects, synthesizers, etc. So modern sound cards just have all kinds of things that earlier sound cards did not have. They have very specialized drivers, sound effects. Oftentimes synthesizers are built into sound cards. Digital recording studios are often housed in PCs and Macs, allowing for multiple track recording. So sound has just come a long way in PCs, and that's not mentioned in your text, but I'm just throwing it in for fun. Okay, so in this section we looked at the audio. Briefly, we looked at the video controller, and we looked at the major types of memory, and just a little bit about how they all interface together. And that concludes our discussion on memory.